As we begin our discussion of multiplying fractions, I want to think back to multiplying whole numbers and think about what that physically means, how we can represent that with some kind of picture. So I have 3 times 2 here, and I want to remind you that that means that we have 3 sets of 2 objects. And if you count out the objects, we have 1, 2, 3, 4, 5, 6. Now we already know 3 times 2 is 6, but when you first learn multiplication, this is probably what you were told. What multiplication is a way to simplify addition. If you have a whole lot of addition, instead of saying 2 plus 2 plus 2, you could just say 3 times 2. We have 3 sets of 2. Keeping that in mind, I want to look at fraction multiplication. So we have 1/2 times 4/5. Half of 4/5. That's the common way this is said. Multiplication can be thought of as of. So half of 4/5. If this was 2 times 4/5, then I would say, okay, we have 4/5 and then another 4/5, and I could just count it out. But this is saying we want half of them. So if I start out with 4/5, I want to take half of these. Now I'm going to do this in a way that's different at first, and then we'll come back to the more obvious way. I'm going to literally split this in half. Look at how many total pieces I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many are highlighted? Well, that's the 4/5. Now, if I want half of what's highlighted, then I have 1, 2, 3, 4 pieces out of the total 10 pieces that I have now. So that's telling me that 1/2 times 4/5 is 4 out of 10. Now, another way to look at this is as 2/5. When I take 4 out of 10, I actually can simplify that to 2/5. And to me, this is the more natural way to think about this. Look at the picture again for the 4/5. If I asked you to take half of the shaded part, wouldn't you just take the first 2 squares? That makes a lot more sense than what I did before, right? Well, that's absolutely right. It absolutely works. This is 1, 2 highlighted out of 1, 2, 3, 4, 5. So this is 2/5. I just wanted you to see that the 4/10 is floating around in there because that's what you get when you actually apply the math to this. But both of these have a physical representation, but in the end, our answer is going to be 2/5. So you can literally see it's half of the shaded region. Now this is easy because half is an easy fraction to deal with. And 4/5, there's 4 pieces. That's divisible by 2. If I said maybe 1/3 of 4/5, this picture would be hard to do. But the idea would still be the same. It would be possible to do a picture, it just wouldn't be as nice. Mathematically, what's going on is we're actually figuring out how many total pieces there will now be by multiplying our denominators. So we can multiply straight across to find these problems. So B times D down at the bottom gives me the total number of pieces. A times C gives me how many are now going to be highlighted. Now remember, you can't have 0 denominators here, so I always put that there. So this is telling me multiply straight across, and you're basically going to do what we just did with pictures mathematically. So let's look at a few of these. You're going to see these are really straightforward. It's literally multiply straight across. I don't even know another way to say it. So 4 over 9 times 2/3, 4 times 2 is 8, 9 times 3 is 27. The next one, 5 over 2 times 6 over 5. 5 times 6 is 30, 2 times 5 is 10. The only complication here is that we need to simplify because both of these have a 0 there, so we actually have a factor of 10 that's shared. If you cancel that out, you get 3 over 1, which is actually 3. And for the last one, straight across, 7 times 3 is 21, 12 times 10 is 120. These share a factor even if you don't immediately see it. If you add up 2 plus 1 is 3, and 1 plus 2 plus 0 is 3, that means they're divisible by 3. And so 21 is obviously 7 times 3. 120 is actually 3 times 40. So when you cancel out that factor, you end up with 7 over 40. Now both these last 2 examples show a shortcut that we can use, and this shortcut's really, really nice. Come back to this example. I could write out the multiplication that we did, and I'm going to do that to illustrate the shortcut. So I said, when I did this problem, I said, okay, let's take 7 times 3, and let's take 12 times 10. However, 12 can be broken up more. We normally wouldn't do this, but 12 is actually 3 times 4. Notice that we have a factor of 3 right in the top and down in the bottom. that factor can be canceled, so now I have 7 over 40. So this is what happened when we simplified that factor of 3. But why do I have to wait till the end to do that? If I cross cancel, I can take care of that factor of 3 before I get to the end of the problem. So again, 7 over 12 times 3 over 10. I look across. Now 7 and 10, they're across from each other. They don't share any factors. But 3 and 12 do. They share a factor of 3. 3 divided by 3 is 1. 12 divided by 3 is 4. Now I multiply straight across. 7 times 1 is 7. 4 times 10 is 40. And I get my answer just like that. This can save you a lot of time because it's usually easier to simplify early than later. For example, look at the first problem here. 1 over 18 times 2 over 9. 1 and 9 don't share any factors, but 2 and 18 do. They share a factor of 2. So 2 divided by 2 is 1. And 18 divided by 2 is 9. Multiply straight across now. 1 times 1 is 1. 9 times 9 is 81. Okay, now, both of these sides share factors in the next one. Look at 21 and 14. Both of those share a factor of 7, right? Because 21 is 7 times 3 and 14 is 7 times 2. So if I take out that factor of 7, I'm left with 3 here, and I'm left with 2 here. And then looking at 12 and 16, they both share a factor of 4. So when I take out the 4 from 12, I'm left with 3. Take it out of 16, I'm left with 4. Now multiply straight across. 3 times 3 is 9, and 2 times 4 is 8. Now, if we hadn't done this, we would have had to multiply 12 times 21, huge number, 14 times 16, huge number. Not that we couldn't handle it, but that's going to be a lot of work to simplify. By taking out these factors now, we were able to simplify pretty quickly. The last thing that I want to make clear, and it's actually not that different, is how we handle whole numbers. I think I mentioned it the last lesson. Who knows? I don't remember. It was one of the lessons. I said, okay, you can write a whole number as a fraction is by just putting it over 1. So if I give you 5 times 3 over 7, what you should automatically write down or think is that's 5 over 1 times 3 over 7. Now the same rules as before apply. 5 times 3 is 15. 1 times 7 is 7. Really, that's it. Multiply straight across, cross cancel if you can.